forward to the next chapter, which is refinery feedstock and products. Because I mentioned as previously mentioned, for the crude oil, they have to go through distillations and to be refined according to the different boiling points. So we can see here, right, the feedstock from the refinery process, the different feedstock listed here. Okay, what is crude oil? Crude oil is a complex mixture of 10,000s of different hydrocarbons. It's very complicated and complex, all right? And it is a dissolved gases, two non-volatiles with a temperature of 1000 Fahrenheit, which is equals to 550 degrees C, and plus boiling point material with the carbon of C1 to C90 plus. And the composition of the crude oil consists of carbon 84 to 87 percentage, hydrogen 11 until 14, sulfur 0 until 5, and nitrogen 0 until 0.02, and others, which includes metals and salts. Okay, the properties of the selected crudes. Okay, because it is known and it is a general knowledge that the crude oil is not created equal. So means that every place, every origin or every country has different properties of the crudes. So for example, right, we can see here for the tapis in Malaysia blend, the specific gravity is the lowest. If let's say we want to compare with the one in Nigeria, Arabian light, Arabian medium, Arabian heavy, Alaskan North Slope and Beta in California, and Shangli in China, Boscan in Venezuela, and Athabasca in Canada. And on the same notation, Tapis blend also has the lowest sulfur percentage with a 0% of nitrogen. So basically, maybe you just have to know the significant properties of the selected group. For example, the one in Canada and the lowest one in Tapis blend, and what can be defined by that. Okay, the chemicals of the petroleum. Okay, it consists. The first one is the paraffins. Paraffins is the carbon atoms connected by single bond, saturated with H, with the chemical formula of CnH2n plus 2. Okay, the example is ethane, methane, propane, and butane and isobutane. It has different physical and chemical properties between normal and isoparaffins. The example is N-octane, which is around 27, and isooctane around 100. And for paraffin, it has high concentration in the crude oil. Okay, next one is naphthanes. Naphthane is a cycloparaffin, means that it is a C rings saturated with the H, right? So means that the H is decreased here from with the chemical formula of CnH2n, and it is classified according to boiling range, and the properties of naphthenes is determined using correlation factors Kw and Ci. This is Watson correlation, and the example is cyclopentane, cyclohexane, decalene. Usually it's started by cyclo because it is the rings, right? Cyclo thing. And next one is aromatic. Aromatic is the one or more unsaturated 5 until 6 carbon rings with the chemical formula of CnH2n minus 6. This is, however, unsaturated bonds, and the example is benzene, toluene, naphthalene, xylene, cumene. And aromatic is denser with the higher octane number compared to paraffins and naphthene with the same carbon number. And next one we have is olefins. Olefin usually not in crude oil, and it was formed usually during processing, which is during cracking process, which will be identified further by one of you during your STL lecture. And the general formula for olefins is CnH2n. And however, it is undesirable in the finished product as high reactivity, which is it is easily oxidized and polymerized to form gums and varnishes. The example is butylene, butene, ethylene, ethene, isopentane, and etc. Okay, next one is we have sulfur compounds, one of the most important influence on crude oil value. Okay, so that's why even though the percentage is very low, but it is really very important to give effect to the crude oil quality. Generally higher lower API and more asphaltic with a higher sulfur content. For example, in thiol sulfides, thiopene, cyclic sulfides, etc. Okay, for sulfur compounds, it has 0.04 percentage in light oil, and it can be up to 5 percentage in the heavy distillates. And for the sour, it should be lower. It should be higher than 0.5, and for the sweet it should be lower than. So this is the range for the sour and sweet, right? If it is more than 0.5, then it should be lower. Okay, next one is for the sulfur, it needs to be removed for the boiling point between 5.696 until 160 degrees C. When it is rated, it will produce hydrogen sulfide, which is not desirable. Okay, I will for the sour and the sweet content, you can refer to the previous slides. Okay. Okay. For the oxygen compound, usually it's going to be lower than 2% with the carboxylic acid, which is also known as naphthenic acid. It is also others as phenols, ketones, ester, ether, and anhydrides. The example is acetic acid, benzoic acid, phenol acid, and cetones. Okay, next one we have nitrogen compounds. Content generally 0.1 to 0.9 percentage. For this compound, it is more asphaltic with the higher N content and high API, but with the low nitrogen content. Higher nitrogen content means that it has higher carbon residue, and it is catalyst poisoning with the gum formation in product for the percentage of higher than 0.25 weight percentage. So basically for the removal, basic and nitrogen low, chlorate dilute with the mineral acid, and the example for nitrogen compound can be pyridine, indoline, perol, indole, and carbazole, etc. Okay, next one we have metallic constituents which occur in the trace of 0.001 to 1500 ppm. Ferrum, cuprum, especially nickel and vanadium, give more deleterious effect to catalyst. The activation results in coke formations. Okay, it tends to be the largest molecules, highest boiling fractions, and whereby 95% of metallic content reduced by solvent extraction with propane or N-hexane.